Hello, I'm Mrs. S from Steps to Success Maths. In this video, we're going to work through GCSE exam questions on linear sequences. We're going to start with the easiest and go right through to the hardest. Pause the video, have a go, and then we can go through it together step by step. Here is a pattern made of dots. Draw pattern number 4. Okay, so you just need to have a look at each pattern and see what's happening. So it kind of makes a cross shape, adding one more dot each time on the outside. So pattern number 4 is going to have 1, 2, 3, 4, 5, 6, 7, and then an extra one on each end, 8, 9, and the same across in the other direction. And that's what it looks like, so I'm going to draw it here. Part B, state the term-to-term rule for the pattern. So the first one has 5 dots. The second one has 5, 6, 7, 8, 9 dots. The next one has 13 dots. So what you can see is it's going up by 4 each time. So the term-to-term rule, how I get from one term of the pattern to the next, is to add 4. Here are the first 5 terms in a number pattern. So 5, 12, 19, 26, 33, and then on it goes. The terms are just the ones that appear. So the first term is the first number, the second term is the second number. It says write down the next term in the pattern. So we need to look at what's happening. Between 5 and 12, it goes up by 7. And it goes up by 7 on each of these. And you need to check it works for each one. So if we add 7 to the last one, we're going to get 40. The next term is 40. Now we want to work out the 8th one. Well, we've got the 1st, 2nd, 3rd, 4th, 5th. We've just worked out the 6th. So the 7th will be add on 7 again. So that's 47. And one more, 54. So the 8th term will be 54. A number sequence has the nth term 4n plus 8. Write down the first 4 terms in the sequence. So we've not come across this nth term before. That's a way of just being able to jump anywhere into our pattern. So n just stands for the position it is, the term number. So the first one will be n is when n is 1. 4 times 1 plus 8. So that's 4 plus 8 is 12. Then the next one will be 4 times 2 plus 8. 4 times 2 is 8 plus 8, so that's 16. The next one, 4 times 3 plus 8, so that's 20. And now you can see the pattern is going up in 4s. So that's 24, and then it would be 28. Luna says 2153 is a term in the sequence. Explain why Luna is wrong. So if you actually look at all the numbers you found in your sequence, you can see they all have something in common. They're all even numbers. So you could say all the numbers in the pattern are even and 2153 is odd. Or another way to solve it is to find the value of n. And for this to be in the pattern, n must be a whole number. So you could say 4n plus 8 must equal 2153. And then if we solve that, take 8 from both sides, we've got 4n is equal to 2145. And when we divide it by 4, we don't get a whole number. So therefore it's not in the sequence. A sequence of numbers is shown below. Find an expression for the nth term of the sequence. So this time we're going to find the rule. So let's look at how we do this. So n is the pattern number. So we've got 1, 2, 3, 4, 5. Then we've got the pattern itself, 2, 4, 8, 11 and 14. If you look at how much it goes up by each time, you can see it's going up in 3s. So that means it has something to do with the 3 times table. So 3 lots of n, 3 times table. You just write out your 3 times table underneath your sequence. 3, 6, 9, 12, 15. And then if you compare what you've got with what the sequence is, so we start with 3, but our sequence starts with 2. Then we have a 6 and our sequence is 5. Then we have a 9 and it's 8. So if we take 1 away from what we've got, we'll get the sequence we want. So we've got 3n take away 1. And that's the nth term of our sequence. And we can use this to answer part B. Work out the 100th term in the sequence. So when n is equal to 100. 3 times 100 take away 1. 300 take away 1 is 299. Here is a linear sequence. Find an expression for the nth term of the sequence. So here we go again. Here's the sequence: 15, 25, 35, 45, 55. We can see it goes up by 10 each time, plus 10. So that means it's the 10 times table, so 10n. Then we've got 10, 20, 30, 40, 50. Now look at what we've got and what the sequence is. So we've got 10 and we want 15. We've got 20 and we want 25. So if we add 5 on, we're going to get the sequence. So it's 10n plus 5. Now we can use this to answer part B. Work out the 52nd term in the sequence. So when n is 52, we've got 10n plus 5. 10 times 52 plus 5. 520 plus 5. 525. The first 5 terms in a number sequence are 4.55, 5.56, 6.5. Find an expression for the nth term of the sequence. So what does it go up by each time? We start with 4.5, then we go to 5. So that's plus 0.5, then to 5.5, plus 0.5, then to 6. So you can see it goes up by 0.5 each time. So this time we need to write down the 0.5 times table, or 0.5n. So 0.5 times 1 is 0.5. 0.5 times 2 is 1. Then 0.5 times 3 is 1.5. And then times 4 is 2. So the sequence we've got so far is 0.51, 1.52. Compare it to the sequence we want. So we've got 0.5 and we want 4.5. So we'll need to add 4. We've got 1 and we want 5, so we need to add 4. We've got 1.5 and we want 5.5. We need to add 4. So our sequence is 0.5n plus 4, the nth term of our sequence, the rule. Now we can use this to work out the 20th term. So when n equals 20, 0.5n plus 4. 0.5 times 20 plus 4. 0.5 times 20, or half of 20, is 10, and add on 4. So that's 14. Here is a sequence: -4, -10, -16, -20, and -28. Find an expression for the nth term of the sequence. So how does it change each time? Well, it goes down by 6. We subtract 6 to get to the next term. So this time we want the -6 times table, -6n. So that's -6, -12, -18, and -24. And now we need to compare it. So we've got -6 and we want -4. So we need to add on 2. We've got -12 and we want -10. So we need to go up 2 again, plus 2. So our rule is -6n plus 2. And we're going to use that for part B to work out the 100th term in the sequence. So when n equals 100, it's -6n plus 2. -6 times 100, add on 2. So that's negative 600 plus 2. Remember, when you add 2, it goes back towards 0. So that's negative 598. The fourth term in a linear sequence is 42. The sixth term in a linear sequence is 60. Work out the nth term of a sequence. So this is a bit different, isn't it? We don't know all the terms, we just know the fourth and the sixth. I'm going to write it out like this. So we don't know the first or the second or the third, but we know the fourth is 42. We don't know the fifth, and we know the sixth is 60. So normally we look at what it goes up by each time. We need to work that out. So if you look at this jump here, it goes across 2 sections, and that is a jump of 18. So each of these little jumps must be 9 plus 9. So now I can fill in my sequence. It must be 42 plus 9 is 51. And I could work backwards by taking 9 off and filling in the rest of the sequence. So I'd have 33, 24, and 15. And now I can use my sequence to find the nth term. I know it goes up by 9 each time. So that's the 9 times table, 9n. 9, 18, 27, 36, and 45. And I can compare it. I've got 9, I want 15. I've got 18, I want 24. So I need to add 6. My sequence is 9n plus 6. I've linked a free worksheet with worked solutions to this video in the comments. That way you can keep practicing so you're confident with sequences. Don't forget, subscribe to my channel so you don't miss out on any of my GCSE maths videos or worksheets.